So here's the second part of our VOP SOP. So we take the average, which we've calculated, and we compare it to a threshold. And then we've got an if statement here, which takes as input the result of the comparison, an increment value, and the current value of the attribute for the point number that we're currently looking at. And this is only executed if the average is over the threshold. So we go inside, you see all that this does is add the increment to the attribute value and produce the result. And we then store that back in our attribute. And the best way to visualize the results of this is to have a look at our 3D view. And I've still got the attribute displayed. We can see at frame 1 this is at the value of 1.1, and as we increment this it passes down the match and these values start to increase. Another way to visualize this was using color. So I'm going to add a group geometry SOP, and I'm doing that after the DOP import, so it's going to operate on the data coming out of the DOP network, and we're going to call it hot group. And I'm going to group by expression, and the expression is going to be $heat is greater than or equal to 1. And so we can see that these points here make it a point group, these points here are in our group, and then we can use a color SOP to add a color, which I'm going to have a nice red color. And we're going to select the group to apply it to, like so. And now we should see, although the 3D view is not always reliable, that as we play the animation, the hot area spreads from one end of the match to the other. And we control the rate of that spread by controlling the increment. So if we increase the increment, then it will move faster. And so on. So the next refinement is to add a bit of variation here at the front of the heat spread, and we can do that by varying the amount of the increment on a random basis. So I'm going to adjust our VOP network to do that, and pause the video and come back. So what we've done to add randomness is create a new parameter called random range. We halve it, and then we create new maxima and minima for the increment by subtracting the random range, half the random range from the increment, and adding half the random range to the increment. And we use this vex node here, which creates a random number based on the point number, and we remap its range, which is in the range 0 to 1, to the new range of the low increment to the high increment, and we do that using this fit range node. And then we feed that into the if statement here as the increment. So this means that there will be a certain amount of randomness in the amount added to our value. And we can visualize this. If we have a look at our 3D view, if we increase the frames, we can see that they're not being uniformly filled with red, but are advancing in a random fashion, like so. We may think that our progression of our flame or heat is still a bit slow, and there's a limit to the extent that we can keep increasing the increment value to speed it up. But fortunately there is another way to do it, which relies on the fact that we're creating these new attributes, we're spreading this heat attribute along our match on a frame by frame calculation. So if we increase the number of calculations we do for each frame step, then the heat will spread more quickly along the match. And on our auto.network node there is a simulation tab with a substeps parameter. If I increase the substeps to say 3 or 4, then it's going to perform that calculation 4 times for every frame, which is going to mean that the heat is going to travel much faster along the match, as we can see. Well, the next stage of our effect is to create the impression of the match burning away, and I've set up the nodes to do this here, and I'll take you through them. The first thing we do is add point normals to our geometry, and we do this using a point SOP and setting the add normals option. I then use another point SOP, and this is adjusting the position of points, and I've added an extra parameter here, distortion amount. Now you can add an extra parameter to any node. You just need to go up here, edit parameter interface, and then you drag and drop the node, the parameter rather, across here into the parameters list. So I've created an extra parameter and I've given it this value, which is based on the point number. We take a random number based on the point number, we then halve it and add 0.5, so we've got a value now between 0.5 and 1, and we multiply it by an amount. And when we're then feeding this into these parameters here, so that we're moving the points in a negative direction along their normals by the amount given here in the distortion amount. And it's this which results in the match crumpling as it burns.